Okay, 5.2 is again using our trig identities, where now we're going to be verifying, and we've talked through these steps in our last chapter. So just to kind of fill in this first page, just to fill it in, we're going to be talking about a conditional equation, meaning we're going to prove the one side equals the other side. We have, when we're looking for solving the equation, an equation that is true for a real value in the domain is called an identity, and that's one of our Pythagorean identities that we have. So in order to verify is proving, you only work with one side. We look for opportunities to factor, to add fractions, to square, and somehow create a monomial. We use our fundamental identities, and if we can, we try converting all things to sine and cosine. When in doubt, try something. Something might work, something might not. It might lead you to something else. Whatever the case may be, don't just sit there and stare at it and not do anything. There's always something you can try. Change things to sine and cosine. Try to get like fractions. Substitute stuff out, especially if there are squares. So there's always something. And that's what this unit is about, is verifying one side to equal the other side, using all of your substitution of identities. So here, secant squared x minus 1 over secant squared, we want to equal sine squared. Well, this is one term on the bottom, and when I have one term on the bottom, I get to split my fraction. So in this case, I have secant squared over secant squared minus 1 over secant squared, because I can separate that out. Well, secant squared over secant squared is 1. 1 minus secant squared is cosine squared. And from our identities, 1 minus cosine squared is sine squared. It checks. And the only way you get better at these is just doing them, knowing your properties. Here I have left side equaling secant squared. Whenever we have fractions, one approach is to get common denominators. So I'm going to multiply by 1 plus sine on the left and 1 minus sine on the right, so that I can get the common denominator. 1 plus sine plus 1 minus sine, all over 1 minus sine times 1 plus sine. Well, on the numerator, the signs go away, and I get 2. The denominator FOILs out to 1 minus sine squared, because the inners and outers go away. Well, 1 minus sine squared is cosine squared. So I can separate this to 2 times 1 over cosine squared, which is 2 secant squared. Check, check. Tangent and cotangent, we want to get them into secant and cosecant. Well, the only thing tangent and cotangent have in common with secant and cosecant is sine and cosine. So this is one of those opportunities where you want to change everything to sine and cosine. So tangent is sine over cosine. Cotangent is cosine over sine. If I have fractions, I want to get common denominator, so I'm going to multiply the first one by sine and the second one by cosine, so that it gives me sine squared plus cosine squared all over sine times cosine. Now I know sine plus cosine. That's one of my identities, so I have 1 over sine times cosine. Well, that's the same as saying 1 over sine times 1 over cosine. 1 over sine is cosecant. 1 over cosine is secant. So secant times cosecant, secant times cosecant. Check, check. Okay. Number 4 gives you a hint. It says instead of working with the left, trying to make something into a fraction is quite difficult. It's much easier to make a fraction into a linear than a linear into a fraction. So what we're going to do is we're going to work with just this right-hand side. And when we're working with that right-hand side, because it is a fraction, we want to use the conjugate. So I'm going to multiply 1 plus sine for that one. So I'm going to get cosine plus cosine times sine by distributing. And you know what? We're going to change that. We're just going to leave cosine and just leave it 1 plus sine. On the bottom, I get 1, and when I distribute, the middles go away, and I get sine squared. 1 minus, so I have cosine on top and 1 plus sine on top. 1 minus sine squared is cosine squared. Well, I have a cosine on top, so I can reduce one of the cosines on the bottom. So now I have 1 plus sine over cosine. I can split that apart for 1 over cosine plus sine over cosine. 1 over cosine is secant. Sine over cosine is tangent. Check, check. I could have distributed up here. I just would have had to factor it back out. So rather than doing that, I just left it without distributing it. And that's going to be 5.2. You're going to practice and practice and practice and use your identities and solve them or simplify them.